this with your Anytone. Rhinoceros, this is Platypus. I am marsupial at this time, over.
What you just saw was probably one of the most basic tests for durability of a radio suitable for use in life safety applications, and that is taking the radio from a standing position with accessories attached, dropping it on concrete, picking the radio up. The radio should still have the battery connected, should still be on channel, turned on with the accessories still attached, and you'd be able to make a transmission on it as you did before you dropped it on the deck. These new radios take this to a whole new level. Hello, this is Brett from SurvivalComms, and today on the table we have the Motorola APX Next XN. This is Motorola's NFPA1802 compliant P25 all-band smart radio. An NFPA1802 compliant radio meets the standards put forth by NFPA for fire service use under Standard 1802. This combines not only an extensive feature set, but also survival of an impressive durability testing regimen. Exposure of the device and accessories to extreme temperatures, drop and tumble testings, and things of that nature. And I went over much of this NFPA 1802 stuff in my video on the Harris XL400P. This radio is capable of operation on 7 and 800 megahertz, UHF and VHF analog and P25 conventional and P25 and legacy Motorola trunking networks. The radio is capable of operation on LTE and Wi-Fi networks as well for the purposes of enhancing coverage using Smart Connect over Verizon and AT&T FirstNet. The radio is capable of storing 3,000 channels or modes, features support for legacy secure net encryption through AES 256, has location tracking using GPS, features Bluetooth, has a smart assistant known as Vicky.
Go ahead. You can query a license plate, driver's license, vehicle identification number, location, or manage unit ID or status. What would you like to do?
Status of unit SurvivalComms.
Current status is on duty.
Thank you, Vicky. And it features 3 watts of audio power.
Wind at 10 knots. At the buoy 13 nautical miles northeast of Ponce Inlet.
This radio also features radio programming over broadband using Radio Central. You can also program it with regular APX CPS. This is programmed with version 31. And this is one of the reasons why I placed a link in the vendor brochure for you to study in the video description, is to go over much of these details in case I missed something. Now, price point of this particular radio is in the $16,000 range. And the configuration capability of this radio is much more complex in its feature set, if that makes sense. So for this content, we're going to stick to the basics that end users will appreciate. And this will give us insight into the valid question from a radio perspective about how much better is a $16,000 radio than a $50 radio or a 30-year-old legacy piece of equipment at the lowest common denominator, which is analog FM. What we are going to do is we're going to review the physical package of the radio and all of its controls. We're going to perform some audio tests comparing this Next XN against contemporary legacy products, and then we'll move on to comparing this radio against a legacy Motorola JT1000 on VHF, an Anytone ATD868VU on VHF and UHF, and what comparison would be complete without throwing a Baofeng in the mix. Testing will be on test equipment so we can be objective in our analysis. Let's get started. It's easy to see that the radio has a smaller form factor than the Harris XL400P, which had the aerodynamic profile of a brick. And in my opinion, the ergonomics of the Next XN radio are superior. You know, the control layout is simple to operate, and it also features a touchscreen, which is visible in full sun. And its menu system is easier to navigate than the one in the XL400P. The user controls antenna and speaker microphone are mounted in such a way that the reinforced upper housing provides protection for these different parts that could be cleaved off of the radio in service. The radio, as per standard 1802, provides all the self-diagnostic fanfare your heart could desire, and this radio is noisier than a cat with a compressed tail when you go out of range or change channels.
Green team. Blue team. White team. Channel 1. Device in non-hazard zone mode. Self-check fail. Self-check fail.
Now, the boot up sequence would seem to take quite some time. However, let me go ahead and...
Trunking Smart Connect. Chicago. Out of range.
But just because it seems to take a long time to boot up, the radio side of it is still live almost immediately after powering it up on the selected mode you're on. So even though our display isn't on, you can still see that we are able to operate the radio as a radio. The battery is a 3400 milliamp hour Haslock battery, and you can see it's much easier to replace this battery than it is on the Harris XL400P. They do offer a radio strap that's made for the APX Next XN, and it's made by Boston Leather in the USA, and it fits the radio well. And it's pretty secure in that enclosure. Let's do a walk around of the APX Next XN and its control set. We will start at what I consider the front, because this is where the speaker is, and we can see the speaker with a large programmable button for Vicky centered there. The battery is also removed from this side, and one of the two microphones is at the top left of the housing. Going clockwise to side 2, we can see a large, well-sprung push-to-talk button and 3 additional programmable buttons. Now continuing our tour, we have come to side 3 and are looking at the touchscreen display. Now it's important to remember that many of these items are able to be customized in your CPS. Now starting at the top right and moving clockwise, we have our RSSI in a bar display format of the LTE network we have configured in the device. Next, we have our radio alias, or the name of the device that we have programmed. Then we have our home button, followed by a menu bar, and the mapping and location menu. Let's go to location here. You can see mapping here. If you have a list of other individuals that may be in proximity to you, they'll be populated here, so you can track them there. At the bottom is the button to turn the touch screen on and off, then the messaging menu, and above that we have a very nice radio RSSI display which gives the relative RSSI and an accurate measurement of the signal in decibel milliwatts. Then we have the channel name text, and above that our zone name text. The icons above this from left to right indicate that we are receiving a signal, that our selected channel is programmed for carrier squelch, and that the channel is in a talk around or direct mode. And let's not forget our clock at the top. Now moving to the top of the radio, going clockwise, at the top right we have our programmable 3-position ABC switch, then our volume and power knob, then we have our 16-position mode selector knob, our RF connector which is recessed within the upper housing for protection, then a large programmable button, typically used as an emergency button. We then have a 2-position concentric switch, which shares an axis with the mode selector knob. And we can see our display here, which gives us our channel details and also critical alerts. Let's talk about the microphone. The microphone is of quality construction. You have a substantial mic cord. The mic cord is replaceable. It's retained with this collar here that is retained with a lock screw to keep it from coming uncoupled. At the front, you have your Vicky button for your virtual assistant. This second light here is not only a flashlight, it is also a beacon light, which will flash in an emergency mode if programmed to do so. On the top of the microphone, we have another programmable button. We have a transmit and receive light up here. We have a volume control paddle, push to talk button, and a programmable button. On the back, we have a substantial clip to affix the microphone to whatever, with a small ring that can be folded up as such. And it also has a small thread, looks like a 1032 machine screw will go into here to affix it to something else if desired to do so. Now we have removed the 3400 milliamp hour Haslock battery, and we can see the radio chassis has integrated rails for the battery and recesses for the battery latch. Towards the top, we can see our battery contacts and our slot for our LTE SIM. Let's go ahead and manipulate the controls while wearing turnout gloves. And you can see it's easy to manipulate the channel selector and the volume control here. Speaker microphone is the same way. Now the touch screen itself is not able to be manipulated while wearing turnout gloves, but while you're encapsulated in an IDLH environment, you should not be trying to manipulate the controls of your portable radio on a touch screen. Now, just like we did in the XL400P video, I'm going to take the Next XN. I'm going to go into a room that's completely dark. I'm going to be wearing my gloves and a respirator. I'm going to turn the radio on, change zones, select the channel that this radio is on, and I'm going to execute an emergency button press, and then I'm going to go ahead and make a transmission.
Rhinoceros, this is Platypus. I am marsupial at this time. Over.
Now I've brought you in the dark room with me. We're going to go ahead and execute the same sequence again. Turn the radio on. It's going to be in the wrong zone.
Trunking Smart Connect. Chicago. Out of range. Conventional. Device in non-hazard zone mode. Device in non-hazard zone mode. Device in non-hazard. Device in non-hazard zone.
Found the channel I need. And hit the emergency button.
Device in non-hazard zone mode. Device in non-hazard zone mode.
And now I've triggered the emergency. I'm not going to lie to you, it was a lot more difficult to complete that evolution with this radio than it was with the Harris XL400P. Let me explain to you what I had to do. I went into total darkness, which you've just seen, how dark it is in there. I had to turn the radio on, and it was in the wrong zone deliberately. I had to use the ABC switch to place it in the correct zone, and then I had to select the correct talk group. And then because the microphone doesn't illuminate the way the Harris did, the Harris had all that fanfare on the microphone, which is rather nice. Find the emergency button, depress it, and then make my transmission. Now, the Harris, being that it has the mode selector on the top of it, made that a lot easier, and all that illumination on top of that speaker microphone also made it much easier to accomplish that evolution. Now, on this particular button here, you can program this to change channel up or channel down, or zone up or zone down, and that would have made it easier, but the problem is when you start manipulating buttons like this to change channels, it's easy to inadvertently hit this button when you intended to make a transmission. So again, I definitely think having a mode selector switch on top of the microphone and more illumination on the microphone would definitely make this much better. Now that we've had an overview, let's get to some testing. On the screen are some basic specs of the APX NEXT XN pulled from the factory flyer linked below. Today, we're going to do an antenna test of the NEXT XN, followed by a subjective P25 and analog audio test of the NEXT XN. Then we will be placing our radio head-to-head against a Motorola JT1000 on VHF, an Anytone on VHF UHF, and a Baofeng on VHF and UHF. And we're going to start with service monitor testing of frequency stability, RF power deviation, and receive SINAD testing of a 25 kHz analog RF channel on VHF and UHF. Then we're going to move to a relative selectivity test and a relative adjacent channel rejection test, and finish with a spectral purity test on my spectrum analyzer. All equipment used in testing is personally owned by me, and this should be a lot of fun. The whip is pretty amazing, VU 7800 megahertz, and I really like it. Look how flexible that thing is. That is amazing, and much more flexible and a slightly lower profile than the Harris variant. But again, the way this thing mounts inside the radio, it's extremely well protected where the RF connection is. Let's go ahead and sweep this antenna and see what our results are. Antenna testing is performed by connecting our antenna under test to a chassis simulator and connecting it to my Onritsu Cellmaster. First sweep is of the antenna on VHF, and the markers indicate where it's hot and where it's not. Now moving on to UHF and on 700, 800 megahertz. P25 audio quality test.
Rhinoceros, this is Platypus. I am marsupial at this time. Over.
Transmitted P25 audio quality test.
Rhinoceros, this is Platypus. I am marsupial at this time. Over.
Received analog audio quality test.
Rhinoceros, this is Platypus. I am marsupial at this time. Over.
Transmitted analog audio quality test.
Rhinoceros, this is Platypus. I am marsupial at this time. Over.
Well, let's go ahead and do some performance tests with the APX NEXT XN. We've got our test box hooked up here to my service monitor. Let's get started. Now we're going to check receiver selectivity. We're generating a signal at 146 megahertz minus 100 decibel milliwatts, and we're injecting that into our radio under test here. We're going to start with our control radio, and we're going to step away in 5 kilohertz increments until we cannot detect the off frequency signal. Let's get started. Okay, megahertz. That is 5 kilohertz away. 10 kilohertz away. 15 kilohertz away. And 20 kilohertz away when we no longer receive our signal. Repeating the test with the APX next, we're at 146 megahertz. 5 kilohertz away. And now 10 kilohertz away, we've lost our signal. JT1000 selectivity, 146 megahertz. 5 kilohertz away. 10 kilohertz away. 15 kilohertz away, and our signal is completely disappeared. Any tone, 146 megahertz, and 5 kilohertz away. 10 kilohertz away, 15 kilohertz away, 20 kilohertz away. Now we're going to perform an adjacent channel rejection test, and this is relative, of course. We're generating a signal at a level of minus 80 decibel milliwatts at a frequency of 146 megahertz, which is where our radio is tuned. Then we're going to generate a second signal 25 kilohertz away at 146.025 megahertz at a level of minus 40 decibel milliwatts. So let's go ahead and turn our radio up. Second signal on now. Second signal off. Repeating the test with the bow fan. Second signal on. Second signal off. Now repeating the test with our Motorola JT1000. Second signal on. Second signal off. Now with any tone. Second signal on now. Second signal off. The Baofeng is in the Christmas spirit as far as spurious emissions. So let's see here. Our fundamental is negative 10.73. And our first harmonic is negative 48. Our next is negative 48, and number 4 marker is negative 52.55. Well, let's repeat the test on UHF. On UHF, this is our Baofeng control radio, negative 5.36. Next, negative 57.75, followed by negative 45.21. And here is our APX Next XN, and our fundamental is negative 11.14. First harmonic, minus 60.84. The following, negative 61.7. And our last, negative 60.1. Next up is our APX Next XN, and starting out at negative 2.88, moving right along to negative 57.62, followed by negative 56.54. So let's go ahead and throw a legacy JT1000 in the mix, and let's see how it performs compared to our control radio. You can see that our fundamental 11.96, first negative 59, next negative 60, and finally negative 60. Here is our anytone on the spectrum analyzer on VHF, negative 10.66, negative 62.1, negative 59.72, negative 58.77. And this is our anytone on UHF, negative 737, negative 5955, negative 57.46. Well, let's go over our testing results. We're going to start with the antenna. I already said I really like the antenna. Its flexibility, it's made of rubber, it appears to be very durable. The way it mounts to the radio appears to be very durable. And the performance of the antenna across all the ranges that we swept was respectable as well. Audio quality, I thought in our limited testing that the audio quality was quite good. Let's go over our results from our service monitor testing. First of all, the NextXN met or exceeded its published specifications in what we tested, which is good news. The RF power column shows us that all of our radios under test are producing RF at a level you would expect them to. Deviation is the same thing. All were well under 5 kHz, with the anytone being under-deviated. Frequency error is interesting. First, let's talk about how the specifications were written for the NextXN. It specifies a stability of 1 part per million, plus or minus, which is basically 1 hertz of allowable error for every megahertz as a rough rule, and is more or less a drift parameter and not a goal. When the reference oscillator is aligned, it is done at the highest frequency of operation and is typically set to a plus minus 50 hertz window, and the magnitude of frequency error should reduce as the frequency decreases. We see that flow with the NextXN and the Anytone, but the Baofeng is inverse for some bizarre reason, and this was a repeatable phenomenon. The JT1000 was the big winner in stability at plus 4 hertz, but it was a product of a different time when crystal quality was better than what we have now, and its performance is an illustration of that. The Anytone was a loser in regards to frequency stability at 400 Hz at UHF, but that falls within the 1 part per million as a rough rule. On analog, it's not a great deal, but on DMR, it's certainly not desirable. The Baofeng on VHF squarely fell out of the 1 part per million rough rule by 43 Hz. Again, on analog FM, not a big deal breaker, but it is an example of you get what you pay for. The winner on receiver sensitivity in our SINAD test was the Baofeng, but all that glitters is not gold. And we will see that in the selectivity and adjacent channel rejection testing next. The NextXN did well, being 1.9 dB down from the Baofeng, but it exhibited superior selectivity. When we look at the sensitivity data, it's important that we consider the selectivity, because that balance of sensitivity and selectivity is what produces a superior receiver. As a rough rule, anything minus 120 decibel milliwatts and better indicates the receiver is sufficiently sensitive for service. Next, we look at the measured average level harmonics emanating from our transmitter. We're below the unmodulated carrier out to 1.5 gigahertz. No surprise, the NextXN did best and the Baofeng the worst. Next is our relative selectivity test. This is where we generated and injected a modulated signal starting at the frequency the receiver is tuned for, and then we adjusted the generated signal off frequency in 5 kHz increments, and the data gathered shows the 5 kHz multiple where the signal was not discernible. The NextXN did best. At 10 kHz away, there was no discernible signal, whereas the Baofeng would detect a signal almost 20 kHz out. Next is our relative adjacent channel rejection test. We took a negative 80 decibel milliwatt locally generated and modulated signal at our tuned frequency, and then generated a second negative 40 decibel milliwatt modulated signal 25 kilohertz away, and studied its effect on our reception of the signal at our tuned frequency. The NextXN and JT1000 did well. Our Anytone slightly less so, but the second signal knocked the Baofeng receiver on its ear. Well, now we can get on to our conclusions. Now, one thing I did want to make mention of is that, someone could make the case that I am not a compliance lab, and they may not agree with my methodology, but I am comparing devices against one another under the exact same test conditions with the exact same equipment. And this is in contrast to a large number of other creators whose testing is opening a box and reading the marketing literature. Personally, I like data and legitimate tests. Consume the content that makes you happy, but I digress. The APX Next XN outperformed the other radios tested under the same test parameters. One other thing that we had talked about in the beginning is I was going to attempt to answer the question, is a $16,000 radio better than a $50 radio? And yes, we will discuss that right now. A $16,000 radio clearly is a better radio in performance and features. It can be trusted in a life safety application. It is built to more stringent standards and subjected to testing for a reason. The $50 radio's price point is its only redeeming quality, and there's really no way to contest that reality. However, a radio hobbyist or non-professional user would be hard-pressed to experience a performance difference between a $16,000 radio and a $50 radio on analog FM. But this is the reason I do what I do. Now, would I buy a $16,000 radio for myself? Nah, I wouldn't buy one for myself. It'd be absurd. But I'm not going to buy a $50 radio for myself either. Let's talk about the pros of the radio. The radio is ergonomic and well thought out to survive the NFPA1802 testing while still being of a reasonable size and weight. The touch screen is a nice addition. I didn't think I would like a touchscreen in a radio, but now that I've played around with this one here, I actually find it to be very nice. It's much easier to navigate, and it's extremely informative. Now, most of the controls of the radio can be manipulated with the use of turnout gloves. All the controls on the speaker microphone you can manipulate with turnout gloves on. The ABC switch, the concentric switch, and the switch that's just above the push to talk, I could not manipulate easily with the turnout gloves on. The audio of the radio is extremely loud and it's clear. And the radio performance was excellent in the testing performed, and the radio met all the benchmarks that were set in the literature for the particular radio based upon, my capability of testing those particular benchmarks. And there's an incredible amount of configuration options in this radio that you can configure in software. Now let's talk about the cons. Now, in my opinion, there may be too much of a smartphone focus on this radio. Making a radio into a smartphone isn't really smart. A standalone smartphone is already an integral part of most users' pace planning, and it provides an alternative talk path. And it also has a reference capability and can be used for mapping and tracking and things of that nature. Typically you don't remove the radio from its holster to look at it and try to use it like a smartphone. Next is adding more illumination and a mode selector to the speaker mic. I talked about this already. When encapsulated in an IDLH environment, the speaker microphone is the control console for the user. The radio doesn't have any DMR or next-in support. And this is a consideration for many users, and workable solutions already exist in the industry. So let's see if we can make that happen. And implementation of an FPP option for techs and authorized users would be another desirable option. In closing, you can see that the radio has returned from whence it came, and if you were at IWCE this week, you will be able to see it up close and personal. I wish to thank those who provided the opportunity for me to share this radio with you, and thank you for watching. I really enjoy creating this kind of content, and I hope you find it useful and entertaining. I hope this helps. This is Brett from SurvivalComms. Until next time.